Right, on today's video, we're going to deal with reciprocal ratios. Reciprocal ratios, we're simply talking about the opposite of your primary ratios. What are the primary ratios? You know them as your SOHCAHTOA. You know, when you say your sine theta is equals to opposite over hypotenuse. When you say your cos theta is equals to adjacent over hypotenuse. And last but not least, when you say your tan theta is equal to opposite over adjacent. Now, when we talk about reciprocal ratios, we're now saying that the opposite of this, but the opposite of these primary ratios, we've got two of them. Under reciprocal ratios, we've got the opposite of sides and the opposite of what? Of angles. So here, what are we going to do? We're going to start with the opposites of sides. So if I'm talking about the opposite of sin, what is it called? The opposite of sin is called cosec theta. So I've got a cosec theta, and the side we invert, meaning to say that what was the denominator becomes the numerator becomes the denominator. In other words, your hypotenuse is now your numerator and the opposite is now the denominator, right? And this is cosec theta when it's the side. And then cos theta, the opposite of cos theta is called secant. Secant theta, which is equals to hypotenuse over adjacent. And then when we go to tan theta, we now say cotangent is equals to adjacent over opposite. Adjacent over opposite. This is how it looks when the reciprocal ratios are what? Are sides. Then if the reciprocal ratios, situations which require angles, you just say cosec theta is equal to 1 over, then you take your sin theta, the angle, so it's 1 over sin theta like this. When it's your secant, the opposite of cos, you now say secant is equal to 1 over cos theta. Then last but not least, your cotangent is equal to 1 over tan angle theta. Now, these are the full names: cotangent, secant, and cosec theta, in terms of what? Instead, in terms of reciprocal ratios, but they've got nicknames or shortcuts. So the shortcut for no, actually this one is the shortcut for cosecant. Cosec is the shortcut. So here I already wrote it in shortcut. But the shortcut for secant is sec, S-E-C. So you say sec theta. And the shortcut for cotangent, it's now cot theta. So cot theta is the shortcut. Now, what are we going to do? What we're going to do, I'm going to now show you how we would deal, or how will we recognize the cosecant, the cotangent, and the secant on a right angle triangle. So on a right angle triangle, how would they work? So we're now going to label the triangle. This is point A, that is point B, and this is point C. This is where our right angle is. And now this angle A, this is where we have got our theta, right? So one thing which I always say, that when you're in an examination of trigonometry or Euclidean geometry, please do not be scared to rotate your paper so that things can make sense. So if I rotate like this, do you see that now it becomes easier for me to recognize the opposite side based on the angle that is in question? This is the opposite. AB here becomes my what? My adjacent. And lunch bar obvious, this is my hypotenuse, right? So now I'm going to rotate once again, and then I'm going to write the sides. So when they say cosecant of angle what? Angle theta. And now I'm going to be using these points, BC, AC, or AB. What is my opposite? My opposite is here where line BC is. So I'm now saying that my opposite is BC. My opposite is BC. So let me write this. Opposite is BC. And my hypotenuse is AC. But remember, under cosecant, we say hypotenuse over opposite. So I'm supposed to start with the hypotenuse, which is line AC. So now I say cosecant is equals to AC all over opposite, which is BC. And like that, I have now written the cosecant, right? Then we go to secant, which is sec theta is equal to, remember it's no longer adjacent over hypotenuse, it's now hypotenuse over adjacent. So where's my hypotenuse? This is line AC over the adjacent, which is line AB. Then cotangent what? Theta is equals to, remember it's adjacent over opposite, which is now equal to adjacent, remember it's line AB, so we write line AB all over opposite, and our opposite is line BC. So as far as reciprocal ratios are concerned, that is how you deal with reciprocal ratios, and that is how you identify them. So let's try and let's meet on the next video. The next video, this was the last video on trig ratios, trig equations. The next video we're going to be dealing with what? On the next video now we're going to Euclidean geometry. Under Euclidean geometry, I'm going to start off with the revision of Euclidean geometry. You know, your fine angles, your straight line, your complementary angles. Then eventually we will start to deal with grade 10 work about Euclidean, whereby we will be now dealing with what? The quadrilaterals, properties of quadrilaterals. That's what we're going to do, right? So if you found this video to be helpful in terms of reciprocal ratios, please don't forget to what? Don't forget to subscribe and share with those that you love. Also, don't forget to like, comment, and with that, let's meet on the next video. Thank you.